Let's talk about moles. So here are some definitions to begin with. So mole is abbreviated to MOL. That's important to remember, not to MOL, mole. And what is it? It's an amount of a substance. It's an amount of stuff. And in fact, 1 mole is 6.022 times 10 to the 23 molecules of that substance. So we're not measuring it in mass, although we're going to come to that in a minute. But we're measuring it in the number of molecules. And this number here, this is very important, and this is called Avogadro's number. Okay, and so I said this is a number of molecules, not a number of grams, but 1 mole does weigh the molecular weight of that particular substance in grams. So what do I mean by that? So for example, 1 mole of carbon-12 is kind of the definitional atom that people use. So that's 6.022 times 10 to the 23 atoms. And it weighs 12 grams, because that's the molecular weight of carbon-12, exactly. Whereas on the other hand, 1 mole of carbon dioxide is the same number of molecules. This is all on its own, so it's an atom, this is molecules, and that weighs 44 grams, because we've got, it's a bigger, more complicated molecule, and it's therefore got a larger mass. Alright, so that's all you need to know, really. Now let me show you how we can start showing you how to manipulate them. So it's important to remember that the number of molecules and the number of moles and the mass all vary together in proportion to one another. Stands to reason if I've got more moles, that means I'll also have more molecules and therefore a higher weight of stuff. So, for example, and this is how I like to do it, with little arrows showing the proportions. And I really suggest that you try and get into the habit of doing this as well. So 6.022 times 10 to the 23 molecules of NaCl. I'm going to use sodium chloride for my examples here. So that corresponds to 1 mole. So that corresponds to 58.4 grams, because that is the molecular weight of sodium chloride. So I looked that up online. Don't expect you to memorize all of these. Alright, so what if I don't have 1 mole? What if I've got instead 0.1 mole? And that's 10 times less, isn't it? So that means I'll also have 10 times less molecules. So I'm going to divide this by 10 as well. So that gives me 6.022 times 10 to the 23 molecules of NaCl. So that corresponds to my 0.1 moles, and also 10 times less grams. That's 5.84 grams. Okay, so these still in the same proportion, but there's just 10 times less of all of them. So similar idea. So I'm going to write out this sentence again myself. No shame in that. So you've got 6 times 10 to the 23 molecules of NaCl is 1 mole, and because the molecular weight is 58.4, the mass of this mole is 58.4. But now what if I don't have 58.4 grams? How about instead I have 10 grams? Now to get from 58.4 to 10, I have to divide by 5.84. So these numbers, I have to divide them by 5.84 also. So this 6.022 times 10 to the 23 divided by 5.84 is equal to 1.03 times 10 to the 23 molecules. If we divide this by 5.84, we get 0.17 mole. Okay, so we've got the same amount, same proportion, less in each case. And same idea, one last one, 6.022 times 10 to the 23 molecules. How about instead of that many molecules, we had 2 times 10 to the 12 molecules. So to get from this number to that number, I have to divide by 3.01 times 10 to the power 11. I wrote that out with my calculator, so I have to divide these others by the same. So for my moles, that gives me 3.32 times 10 to the minus 12 moles. And here, divided by 3.01 times 10 to the 11, that gives me 1.94 times 10 to the minus 10 grams. Okay, so again, these are all changing together. So a mole is this many molecules of a given substance, and that relates to the weight that you've got in a way that depends on the molecular weight of the particular molecule that you're interested in.